Welcome, everyone. Today, we are exploring a critical component of machine learning operations, managing the complete model lifecycle. Our main focus will be on the later stages of this journey, specifically how we register, version, and ultimately archive models securely and effectively. Let's elevate your MLOps strategy. Let's begin by defining the machine learning model lifecycle. Traditionally, data scientists spend all their energy in the inner loop experimenting and training the model. But as senior engineers, we know the real challenge begins in the outer loop managing that model once it leaves the notebook. The model lifecycle is the complete journey of a model from its creation, through its active use in production, right down to its eventual retirement. Why is this critical? Because without strict lifecycle management, companies suffer from model sprawl. You end up with hundreds of undocumented models running in production, costing money and introducing risk. How do we solve this? By implementing a rigorous state machine. Every model must exist in a clearly defined state: development, staging, production, or archived. For a deep dive, understand that this isn't just about clean code, it's about governance. A managed lifecycle aligns your technical artifacts with stringent enterprise compliance and security standards. Take a look at this state diagram. It perfectly visualizes the strict lifecycle phases we just discussed. A model begins in development during the training phase. Once successful, it transitions into staging for registration and testing. Upon approval, it moves into active production. Crucially, notice the final transition from production to archived. Models don't live forever. When a model degrades or is replaced, it must be officially transitioned into the archive state before reaching its true end of life. Before we can manage a lifecycle, we must have a foundation of registration and versioning. What is model registration? It is the process of taking a raw, trained model from your compute cluster and storing it as a governed, official asset in a centralized repository, using tools like mFlow. The absolute basic rule here is versioning. Every single time a model is registered, it receives a unique, immutable version number. Why do we enforce this? Reproducibility and safety. If version 2 of your model is deployed and suddenly starts failing, you must be able to instantly roll back to version 1. How do we ensure this happens consistently? We automate it using GitHub Actions. When code is merged, the pipeline automatically trains and registers the model. Diving deeper into enterprise MLOps, remember that we don't just version the model weights. We version the entire lineage, the data used, the hyperparameters, and the Python environment. This guarantees we can exactly recreate the model years later. This sequence diagram maps the automated registration process. Our GitHub Actions pipeline triggers the training script on Azure ML Compute. The compute cluster trains the model and pushes the resulting artifact directly to the model registry. The registry securely stores it, along with all the lineage and metrics, and returns a strict version number like v2 back to GitHub. This creates an unbroken, auditable chain of custody from your source code directly to the registered model. Once our models are securely registered and versioned, we must manage their active lifecycle states, staging, and production. What does this mean operationally? It means using tags within our model registry to dictate exactly where a model is allowed to run. The basics dictate a strict progression. A newly registered model is first tagged as staging. Why? Because you never expose live business processes to a new model without testing it in a mirrored environment first to catch integration errors. How is this managed? You use registry APIs to update the model state. Your deployment endpoints are programmed intelligently. They don't point to a static version number. They point to whichever model currently holds the production tag. For our deep dive, consider the transition itself. The safest way to move a model from staging to production is using a shadow deployment. You route a copy of live traffic to the staging model and compare its predictions against the live production model. If it performs better, you update the tag. Look at how tags govern routing in this flowchart. The central model registry holds all versions. Version 3 is assigned the staging tag, routing it to the integration testing environment. Meanwhile, version 2 holds the production tag, actively serving the live endpoint. Notice the dotted line representing shadow traffic flowing from the live endpoint to staging for real-world validation. Once validated, the orchestrator promotes the tag, seamlessly shifting version 3 into the live endpoint. A model doesn't stay in production forever. We must identify its end of life through continuous monitoring. What does this entail? It means actively tracking your live model to detect performance degradation. The basic truth of machine learning is that models degrade over time. Why? Because the real world changes. Consumer behavior shifts, markets evolve, and the live data drifts away from the static data your model was trained on. A classification model that was highly accurate 6 months ago might be actively harming your business today. How do we catch this? We utilize tools like Azure Monitor and Application Insights to track real-time telemetry, token usage, and prediction drift. Diving deeper into automation, this monitoring shouldn't just be a dashboard you look at. When data drift crosses a critical threshold, it should automatically trigger an alert that orchestrates your GitHub Actions pipeline to train a brand new version of the model, effectively restarting the lifecycle. This flow illustrates the continuous monitoring loop. Our live production model is constantly watched by Azure Monitor, analyzing telemetry and outputs. We hit a continuous decision gate. Is data drift detected? If no, the model continues serving traffic. But if yes, the system takes the right path, triggering a retraining alert. This automatically spins up compute to train a new model version. Crucially, this success leads to the final step, demoting the old, degraded model from production. When a new model takes over, what happens to the old one? We do not just delete it, we archive it. What is model archiving? Archiving is the intentional process of removing a model's active status and locking it into a read-only, inactive state within your registry. The basics of lifecycle management dictate that when version 3 goes to production, version 2 goes to archive. Why is archiving so critical? It comes down to compliance and accountability. If a regulatory body audits a financial decision your AI made 2 years ago, you must be able to prove exactly what model was running and how it was trained. How do we enforce this? By applying the archived stage tag in the registry. For a deep dive, understand that archiving severs the model from all live endpoints, so it cannot be accidentally queried by users. However, it preserves the immutable artifact. A data scientist can still download an archived model into a local notebook to run retroactive debugging and satisfy legal inquiries. Examine this transition flowchart. Inside the model registry, a lifecycle transition occurs. The orchestrator promotes the new version 3 into production, where it receives live user traffic. Simultaneously, it demotes version 2 into the archive state, represented by the gray dotted box. Version 2 is completely disconnected from live traffic. Its only outbound path is a read-only connection explicitly reserved for audit and debugging purposes by authorized personnel. Archiving requires strict governance. What is archiving governance? It's the establishment of technical rules that dictate exactly how models are retired and protected. The absolute basics of this phase: you must ensure that archived models are completely stripped of their compute resources. Why? Because an abandoned model endpoint left running in the background will consume massive amounts of expensive cloud budget while doing absolutely nothing. Furthermore, it remains a security vulnerability. How do we govern this? We apply Azure role-based access control. Once a model is archived, its permissions are restricted so that only highly privileged accounts, like a compliance officer, can view it. Diving deeper, archiving shouldn't be a manual cleanup task. You must integrate it into your CI/CD pipelines. When your GitHub Action successfully deploys version N to production, the very next automated step should explicitly update the registry tag for version N-1 to archived and systematically delete its associated compute endpoints. This sequence diagram maps the automated governance of archiving. The CI/CD pipeline deploys version 3 to the managed endpoint. Once the endpoint confirms that 100% of the traffic has successfully shifted to the new model, the pipeline immediately takes action on the old model. It contacts the model registry to update version 2's tag to archived. Then it instructs the endpoint to physically delete the version 2 deployment, freeing up compute resources. Finally, the registry locks the version 2 artifact in a secure, read-only state. As experts, we must understand the crucial difference between archiving and permanent deletion. What is the difference? Archiving retains the model artifact and its metadata securely in storage. Deletion permanently erases it from existence. The basics are simple, but the why is complex. Storage in the cloud is cheap, but it is not free. While compliance demands we keep old models, hoarding thousands of obsolete, massive deep learning models violates the principle of data minimization and inflates your bill. How do we strike a balance? By establishing an automated data retention policy. A standard rule might dictate that models remain archived for exactly 3 years for auditing purposes, after which a script automatically executes a permanent deletion. For a critical deep dive, you must consider data sovereignty and privacy laws like GDPR. If a user exercises their right to be forgotten and your model contains memorized representations of their PI, you may be legally obligated to permanently delete that specific model version immediately, entirely bypassing your standard archive window. This flowchart defines the end-of-life logic for a model. Once removed from production, it enters the orange archive state. It sits in a continuous loop governed by the retention policy check. As long as it is under 3 years old, it remains safely archived. If it ages past 3 years, it routes to the red permanent deletion node. However, notice the secondary trigger, a compliance or GDPR event. If a legal right to be forgotten request is validated, it creates a fast-track route, immediately sending the archived model to permanent deletion regardless of its age. Let's apply this to a critical, real-time use case. Imagine Prosware, a healthcare startup. They recently deployed version 2 of their diabetes classification model. However, a week later, Azure Monitor alerts trigger. There is massive data drift, and the model's accuracy is plummeting, risking incorrect patient diagnostics. This is an emergency. They need to restore reliable service immediately while the data scientists figure out what went wrong with version 2. Because Prosware follows strict MLOps lifecycle management, they didn't delete version 1 when they upgraded. They properly placed it in the archived state. The execution is swift. The DevOps team triggers a GitHub Actions pipeline that simply pulls the pristine, archived version 1 artifact and redeploys it to the live endpoint. The result, diagnostic accuracy for patients, is restored in minutes with zero code changes required. Version 2 is then demoted to the archive for safe, isolated debugging. This scenario proves that archiving isn't just about legal compliance, it is the ultimate operational safety net for your enterprise AI solutions. In our final sequence diagram, we witness the Prosware emergency rollback. Azure Monitor detects the issue and sends a critical alert to GitHub Actions. The CI pipeline instantly acts, requesting a rollback from the model registry. The registry unarchives the stable version 1 artifact. The pipeline pushes version 1 back into the live endpoint and deletes the failing version 2 deployment. As stable service is restored and monitored, the pipeline finishes by tagging the failed version 2 as archived, securing it for the data science team to safely investigate.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material. So this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.